Welcome to a new test and teardown video. This time it's another Boonton, a capacitance bridge model 74Z. This one is of course completely tube based. In the manual it says it's from 1962. I got this one for free from a guy at the local ham radio flea market, and it was a given up radio amateur repair project. We got all the screws missing, we got loose parts inside, and this one is the 117 volt AC only model. So it's with the original American plug. Look at that, real vintage stuff. Did I say that this one measures at 100 kilohertz? There's an oscillator inside. The measurement range is from 0.05 picofarad to 11 nanofarad. That's all it can do in 4 ranges. So we play with the multiplier right here. I found one on eBay, and I think it was $295, and it looked like a little bit more beat up than this one and a little bit different models. We will have a little bit of different models with different switches and connectors and stuff in this area, I think. And yeah, we got, I think it's 4 or 5 tubes in this one, but let's open and investigate and see what is the status of this one, because I also hear some loose parts when I move this around, so yeah, I better open. Inside the bottom view, the mains cable, oh, can you hear this? We got those clickety-clackety sounds, and I'll show you what happens with this type of plastic. See? It just falls apart like this. And this also, click, also happens inside the cable for some funny reason. So this I have to replace. It looks like the mains fuses, I mean the holders been replaced because they were supposed to look the same, but we got 2 fuses. Well, a little bit extra nice. Oh, 6C4. So there is a tube in here, right? Yeah, that is where it is. It's hidden inside here. So this is probably the oscillator inside a nice little cabinet. Let's look at all the different capacitors. Everything here looks real nice and fine. That's a little funny special capacitor. But here at the bottom, well, you can't really see any kind of leakage. There's a funny shielded cable right there. Coax cables done like that to access the measurement signal. And that one here is, why did they do that? Very special indeed. A little bit of fungus on those wires, but anyway, other than that, quite all right. And here is the oscillator with the little shielding box removed. And they tried to shield it really good with all this. Seems like they solder it to the case, and how can they do this? This looks like aluminium. So that is a little bit tricksy. How did they do that? Yeah, here and everywhere. This is the 6C6 triode. It's quite a simple oscillator, by the way, with this inductor down here and a tapping in there for the output. So it should be fairly easy for me to see if this one is oscillating at 100 kilohertz. And there is a trimmer here to adjust for the 100 kilohertz. And that frequency is important. And I will get back to that in a second. And if we look here from the top, we see the two 6AU6 pentodes. And they are a part of the detector amplifier circuit. And also, if you see the transformers and filters and all that here, it's quite clear that this entire system here is specially tuned for 100 kilohertz. Of course, that is how this system works. Nicely shielded. Oh, by the way, those pentodes, the grid is controlled directly by the 150 volts from the OA2 voltage reference. So that's actually all it does. This voltage reference makes the 150 for the gain set grid, and then it sets a bias and all that kind of stuff in here. So that is more or less. I should probably show some schematics. Oh, by the way, this unit here, I don't know if you can see, we got a little screw down here, or a little nut, and here as well. Also, right, there is a screw. See, we got some screws all the way around. Missing screw, and screw. All right. So this reveals there was supposed to be a nice shielding case around this entire unit. And it's also isolated from the chassis. You can see those little standoffs here with isolation. And again, isolation for all the screws. Those will be fine adjustments for the resonant point. You actually zero. This is the top capacitor mounting. There's a hole in the top chassis. You can open this hole and then you can access those. And the idea is you zero with these two here. And this way, it really doesn't matter much with all those cables and all the long wires and all that kind of stuff, because you zero with these. They tried to make those wires goes in nice parallel in here so that everything zeroes out. It's actually quite funny the way they managed to make the wires fly all over the place. I think you call this the measurement assembly, or this block with all the capacitors and stuff like that. Tuning components. But I really don't see why I shouldn't be able to power this up, because it looks quite alright. Nothing burnt, nothing blown up. So let's just try and give this some power and see if we're lucky. How is this going on the first power up? Let's just mains is applied, and it is using 30 watts, 20 watts, 18. And I also got a scope connected to the output. So yes, we got output. Hoppa, nice. And 24 watts. I constantly monitor the... Okay. It is, this is AC modulated. So there's a very, very powerful AC hum on this. And you can see this if I crank down. See? This is AC. It is probably not supposed to do that. So there's a completely missing rectifier capacitor. So we have total AC modulation on the high voltage. That is definitely my take on this one so far. So I'll go and replace that capacitor. You're not going to believe this. So when I wanted to measure the voltage on this one, I just poked a little bit on this wire. I mean, look at the soldering. There's no soldering. This wire here is the ground for this capacitor. Really? Not soldered. Maybe that is why it's not working. Let's just try and remove this one for a second and measure the capacitance. Clickety clickety measure. Is there anything, oops. Is there anything good in this capacitor? No. No. It says overload and all that kind of stuff. It's probably because we still got a little bit of voltage left in this thing, and then my meter just do not like it. Well, I actually try and solder it first, and then let's see. So that is with this capacitor soldered. It still definitely is AC modulated. I cannot believe that. I think I will try and put in a new capacitor and see if it's better. So maybe we should look a little bit on the schematic and compare with my unit, because that is the only big capacitor we got. And that one is definitely connected to the high voltage system in the detector amplifiers. But here is the rectifier tube, and the output from the rectifier tube goes to the inductor. And then it goes to this tiny little capacitor to ground. And then it goes, I think it goes via this one here, and then this one probably to that system up here, right? Whatever. The thing is, my unit definitely doesn't match the schematic. So here we go. If we look at the schematic, we have the rectifier tube going to a capacitor, then through the inductor, and then to another capacitor. I believe those two capacitors, they are inside one capacitor. And there you have it, right? But if we look at my unit here, both of the capacitors, they are connected in parallel up here. And I don't measure any kind of microfarad here. I measure 0. So I will try and replace that capacitor. I'll just take this one. I think 47 is more or less the same as 20 plus 20. It's very close. I'll just solder this one across here, and let's run a new test and see if it's any better. And there you have it. Now we can change the trigger to channel 1. And now we have a nice sine wave that is nice and stable. It says 100.8 kilohertz, so I just dial. See? I can fine tune the oscillator to exactly 100 kilohertz, because I know the filters in the amplifier is tuned for that frequency. Maybe the alignment procedure is not to put this exactly to 100, but to find the peak. So what we could do is look at the null indicator right here. Just put it, see, somewhere. And then I play with the frequency. Oh, look at that. And then it goes up. Here, it is the highest. So now I just leave it there. This is 104.9. Well, that reveals my amplifiers in my detection system is tuned for that frequency. Ha ha, that is a nasty trick. Of course, my tuning here is not, yeah, you see, I'm probably not tuned for anything here. Now I'll try and see my little capacitor. So this capacitor I got here, that was actually already mounted in my unit. It says 39 picofarad, but in reality it is 42. I measured this one. So I got 42. I will of course remove my scope and then I will play around with this unit and see if I can get it to read. I got kind of good news. We got a lot of loose connections in this system here. For conductance, that means the series resistance and all that kind of stuff. But I try not to touch it because I finally made a contact in this one. Damn it. This is typical when I want to show. Oh, good. I fixed it. So this is the capacitance. Okay, now I am in multiply by 0.1. So that means I set 42 picofarads. But look here. Got a 0 here, and then it goes up, and then it goes up. So I know it is 42. So this is 40. See, 40, 1, 2. What I can do is I can of course tune here. So now I've calibrated this unit. So now it reads 42. I think that is fascinating. It's actually measuring correctly now because now it's calibrated for the correct capacitance because I know what I got right there, right? Let's see if I touch this one just barely, see? Oh, crickety, not working in any kind of way. So that is the failure mode of this unit. But if I only fix this, then it's going to be working. Not able to get a good contact again. This is, oh, here we go. Crackety. See? What a fun day. Here is the schematic of the oscillator. We see the 6C6 triode coupled together with the inductor, where you can adjust for the frequency. In this inductor, we have a tapping that goes to the next stage. And it's quite simple. There's this switch on the back of the unit that says low and high, and that is the drive level of this oscillator. Here is the schematic of the detector. This one uses 2 pentode tubes and 3 resonant circuits, and they are of course tuned for 104 kilohertz. We figured out by adjusting the oscillator frequency we could fine peak tune to maximum output of this one, and I think that is the whole idea about how you tune the oscillator. Otherwise you have to retune all those 3 stages, and I was too lazy to do that, of course. Like I said earlier in the video, the 150 volt is a regulated voltage by the OA2 tube, and this one goes into the amplifier grid that sets the gain and bias points, and then you have a maximum gain in this stage by the cathode is decoupled directly to ground. So that means you have a maximum gain, obviously, in this circuit. And then there's a little diode, and this diode generates a DC voltage that drives the meter. Here is the schematic of the whole tuning box. And oh my goodness, a lot of switches, a lot of capacitors, and a lot of transformers and all the nice bits and pieces. And I will spare you all the funny details here, but I kind of like the way they made the schematic. You can see the big adjustments in the center here. This is the tuning capacitance and how this affect the test point and all that. I mean, just amazing, fantastic schematic style. And if you just sit down here and have a little look on at this, and you have your unit, and you have a range that is not working and all that, you should be able to easily figure out what is going on. And I kind of like it, really. So here's the potentiometer, full of all the annoying loose connections. I mean, it should be possible to get in there and change this. I think I can just unscrew here, and look at that. I got service holes here. I can go in with a screwdriver and here and desolder just this and then pull this out. I can even access the set screws, and that means I will be able to replace the potentiometer. Also clean the range switches of all this stuff that is related to that potentiometer, because these two things, they're of course connected in series, right? All those ranges and all that. But then it will be up and running once again. This good old meter from 1962. What a fun day. Anyway, I think I will call this a day. And thank you very much for watching. I had a little bit of fun with this one. It's gonna be fantastic to get it up and running in full effect. But I think you got the point. See you around. Bye bye.